Hi, this is Jyotsna. Let's explore some basic concept of machine learning. In this video, I would like to explain some learning paradigms such as supervised learning, unsupervised learning, reinforcement learning. Firstly, what do you mean by the learning paradigm? The learning paradigm in machine learning refers to the approach a model takes to acquire knowledge from data. Let's start by understanding these terms. The supervised learning is called supervised because the machine learning model learns from data samples where the output is known in advance. In supervised learning, the model learns from the labeled data. Imagine there is a teacher for guiding a student. The algorithm is provided with input data along with some correct answers. And it's the task is to learn and underline the pattern and relationship that connect the two of them. Once trained, the model can make predictions or classifications on new unseen data, just as a student can answer questions in a test paper. Suppose we have input variables, m input variables and n output variables, and there is a mapping function n equal to f of m. To learn such mapping functions, as in the case of mathematics, we need an algorithm whose key objective is to approximate the mapping function so well that one can easily predict n. The output variable for new input data can be predicted. Some of the famous or well-known supervised machine learnings are k-nearest neighbor algorithm, decision tree, logistic algorithm, logistic regression, support vector machine, and random forest. Based on the way in which this learning algorithm is performed, supervised learning can be divided into two types, classification and regression. Classification is based upon the task to predict categorical output responses or labels from a set of input data. The output which will belong to a specific, discrete, or finite category. For example, if you want to predict someone will click your ad or no, the output will be yes or no type answers. For this kind of task, we can go for classification supervised learning. But in the case of continuous numerical output responses, where the labels for a given data is infinite, we have to choose regression. This output will also be based on what our machine learning model learns in the training phase. For example, you have to predict the price of a house or a building based upon the set of given tables or data given in a table, then these kind of supervised learning will comes under regression. Now let's shift our focus to unsupervised learning. As the name suggests, in the unsupervised learning there won't be any supervisor. Let's make it clearer. Suppose we have input variables m. As opposed to supervised learning methods, there would not be any corresponding output variables or final categories are not given. So from the given input data, we have to find some patterns. In this paradigm, the model explores unlabeled data, much like a detective uncovering hidden connections. It's a fascinating approach where the algorithm's goal is to find or identify patterns, structures, or groupings within data without any guidance. Let's think unsupervised learning as discovering hidden gems within the treasure trove of information. There are mainly four different methods used in unsupervised learning. First one is clustering, where we find some patterns based on some similarity measurement. After finding these patterns, unsupervised algorithm cluster these or groups these input data based upon the similarity into different groups. If the data set is very large or we can't manage the data, we have to go for the association. Association is very similar to clustering, but one of the best example of association is analyzing customer shopping pattern. What would be the interest of customer, or what will he buy along with other items? These are comes under association of unsupervised learning. Next is dimensionality reduction. As the name suggests, we have to reduce the number of feature variables. If you have n number of feature variables, we are representing the n number of feature variables with a few number of feature variables. To do this this method, it selects a principal feature, which is the major one. We have to omit the other one. Example is principal component analysis. The next one is anomaly detection. Anomaly detection find occurrence, anomalous observations, or the patterns which is not similar to the other one. These are all comes under unsupervised machine learning. Lastly, we have reinforcement learning. This is where our model becomes an agent in an environment, taking actions to maximize a cumulative reward or minimize the penalty. It's like teaching a dog to learn when to eat or to jump and all. Okay. The algorithm learns through trial and error method, receiving feedback from the environment and adjusting its actions according to the penalty or reward we have given. Over time, it becomes adept at making decisions, a better decision to lead the best outcome. For this reinforcement learning, there are some steps where we have to follow. First, you need to prepare an agent with some specific set of strategies. Now, this agent will handle current state of the environment based upon the agent's observation, select some optimal policy and perform suitable actions. Based on this action taken, the agent will provide reward or penalty. Finally, update the set of strategies used in step 1 and repeat this process from step 1 to step 4. This is the usual steps follow in reinforcement learning. Now let's go through some examples. Tell me which type of learning is this? Here we have given a set of images of red apples as input raw data. The supervisor will train the dataset and there will be an algorithm. After processing, even if you give a green apple, the machine can find out that it is an apple because this is a supervised learning. We have some categories or labeled data given as output. This is an example of supervised learning. The next will be example of unsupervised learning. Here the input raw data is not categorized or we don't have any output categories. Even if we don't know the output categories, we find similarities between these images of apples and bananas and mangoes. From that, we can just group them into 3 different classes. This is done in unsupervised learning. Finally, as I told you, the example of a dog to feed the food is reinforcement learning, where we condition the dog to wait for the bell and have the food. Now let's examine this table, which is a comparison of supervised learning and unsupervised learning. The major objective of supervised learning will be to predict as per the human expectation and to train the algorithm for this prediction. Whereas unsupervised learning will find insights or the similarity patterns from a large volume of unclassified data. Here in the case of supervised learning, data set labels are given. We know the classes prior to the execution of the program or execution of the algorithm. But in case of the unsupervised learning, we don't know the classifications or categories. The dataset is unlabeled and we don't know the classes. In supervised learning, a kind of human intervention is required, but in the case of unsupervised learning, we don't need such human interactions. Proximity to the artificial intelligence is much more in unsupervised learning because less amount of human intervention is needed. Computational complexity will be complicated, time consuming, and requires more resources in the case of unsupervised learning. Supervised learning is simple and inexpensive, whereas unsupervised learning will be more complicated and expensive. Learning process in supervised learning takes place usually offline, but unsupervised learning take place in real time. Accuracy is less in case of unsupervised learning because we don't know the labels. Okay. Next is the applications of machine learning, or there are more than 10 applications. I cannot even count where these machine learning is useful. You can use in healthcare, finance, e-commerce, NLP, natural language processing, sentimental analysis, chatbots, image video analysis, facial recognition, action recognition, autonomous vehicles where we drive the car self-driving cars are available, manufacturing industry, environment science, um, and there are a lot more. Okay, now let me wind up this video. Thank you. Have a wonderful day.